Welcome back to my YouTube channel. Bismillahirrahmanirrahim. Assalamu alaikum. So today in this video I am going to teach you NLP all steps. So basically you are going to master your NLP journey. You might be thinking that how to start NLP and what are all the necessary steps in NLP, like tokenization, cleaning textual data, multi-level classification and multi-class classification. So we will be covering all these things in this video. But if you have not accessed this playlist, NLP transformers projects, you need to access it and watch the previous videos. So let's get started. Now first of all, let me assure you and let me clear you that why I am saying that you are going to master NLP all steps or master your NLP journey. So basically NLP is nothing but natural language processing, and in natural language processing we deals with textual data. Okay, now in this video you are going to cover, first of all, in your data there might be classes. So what is multi classes or what are binary classes? Okay, so first of all we have to identify that and how to encode and tokenize that classes. Secondly, sometime in textual data in your target column there might be multi labels. Now you might be thinking that what is the difference between multi classes classification and multi labels classification. This is quite interesting part of NLP and textual data. After that we'll be covering that how you deal with the input column. Now in input column you will have text. Okay, so how to clean that text, like removing stop words, links, special characters. So I'll be covering all that step. Okay, after that, how to deal with tokenizer. Now when you deal with large language models like transformers, there they provide you a tokenizer, and that tokenizer have a lot of parameters like padding, truncation, max length. So we will be covering all that things in this video as well. After that we will be covering how to deal with the target column either in multi-class data or multi-label data or binary label data. So how to deal that and how to categorize them. So let's get started by the first step, and the first step is input text cleaning. Okay, now in textual data you will have normally two columns. The first will be text containing text. Okay, this is actually NLP, and there will be a target column. It could be a multi-class or multi-label or binary label. Okay, now before proceeding or before feeding the input text column to your large language model or NLP model or machine learning model, you might need to clean that text. This is the text. He was HTTP's Noor. Now this is a link. We don't need to keep it, and we don't need to train model by links. Okay, very nice. After that we have some special characters, player with loving. After that we have an emoji, intelligently. Now this is a single sentence. In your entire data set in text column you will have maybe 3000 rows. It could be 5000 sentences, right? So you have to clean all that sentences one by one. Right now in that sentence you have to remove all the links, all the special characters, all the stop words, and especially stemming and lemmatization. Let me show you. So I have a Python function def clean. This function takes a text. So it will take the first sentence from your data. After that, once it clean it, after that it will take another sentence. Now first of all you have to do lower casing. In your sentence there will be upper letters like he. In he we can see H is upper, so we have to make it lower. Okay, after that you will apply a remove stop words. Stop words are those words that are not necessary for our model, like verbs, okay, like prepositions. So was is not necessary. Okay, we don't need to keep it, we have to remove it, like is, am, are, from, is, to, all these things. Okay, and with is a preposition, so we don't need it. Okay, after that you have to remove special characters. Sometime when creating data set or writing text like data analyst or taking data from Twitter or some social media accounts, there you will see links and special characters like tags. You have to remove all this. Okay, and emojis, we do a lot of emojis in social media, on Twitter or on Facebook, so we have to remove that as well. Okay, now once you apply these four steps, lower casing, stop words removing, special characters removing, emojis, your sentence will become like this. So currently we have he. Now first time it was capital, but this time it's lower. He, we didn't apply yet links, so links will be present. After that nice, so we removed was because was considered as a stop words. Where is actually I think it's a preposition, so we have to remove it as well. Nice is an adjective, we have to keep it. After that we have special characters, so we have removed them. Player is a noun, we have to keep it. Loving, intelligently, right? Now after that we have to do some more steps like removing links. So once I apply this links, you will see the sentence will become like this. Now here in this sentence you might be seeing love. First time here it is loving, now this time it's love, so that was the fourth form with ing, loving, and it's become first form, base form. So stemming is actually in your sentence all those words with third form, second form or fourth form, we have to move it to the base form, to the first form, okay, so that model can understand very well. So all words like loving is the fourth form of love, so we have to make it love. This is called stemming, and it could be happen for all words like with third form, fourth form and second form, we have to make it first form. Lemmatization is similar to stemming, but the only difference is that it could make words to the base form in the sense of adjective and adverb. So intelligent is an adjective, but intelligently is an adverb. So making word to the adjective from adverb will be known as lemmatization, right? Like intelligent, intelligently, or intelligence. If there was intelligence, after applying lemmatization it will become intelligent. If there is intelligently, applying lemmatization it will become intelligent. I hope you get the idea. So these are some basic and necessary steps while cleaning the text column, the input column, so that we can prepare it. So finally we will have this sentence: he, nice player, love, intelligent. Okay, and this is just a single example. If in your data set you have 5,000 rows or 5,000 sentences, it will be applied for each and every sentences as well. Okay, and we will do all these things practically in code, and we have already done in a lot of my project in this channel. Okay, now this is the most important, my favorite and most usable step in large language models like transformers. So tokenizer is nothing but a class provided by Hugging Face. Okay, Hugging Face transformer library. Now actually in tokenizer we pass the input data, the text column. After cleaning we have to pass it to the tokenizer so that we could convert it into integer values. So what we do, let's say we have this sentence: he, nice player, love, intelligent. This is the first sentence. Second we have I love code, and third we have just let me check the recording, just give me a few minutes. Yeah, so where I was there, and let me make it, sorry for the interruption. So we have basically these three sentences. Now in the first sentence we have, I think, 5 words: 1 2 3 4 5. Okay, so the length of this sentence is 5. The second sentence has 3 words, the third sentence has 2 words. So in this entire corpus, let's consider this is the entire data in which we have 3 rows, but in reality you will have 5,000, 3,000, we don't know. Okay, but currently we have only 3 rows or 3 sentences. So here we have to get the maximum length. So the maximum length in this entire corpus comes from the first sentence, that is 5. Okay, so we consider the max length is okay. By mistakenly I have written here 4, so consider it 5, right? Now in tokenizer, first of all we will pause this entire corpus. So let me give it a name to this entire corpus: text. So text is a parameter in tokenizer. Here my data set name is df train. In this df train I have all these text, and there in df train I have a column by the name of text. I am passing only this text, not the target column. Okay, so I have just passed the text, and we convert it explicitly to list. Okay, so basically this step is coming from this entire corpus. After that we add special tokens. What is special tokens? I'll show you a bit later. We keep it true. Max length will be 5 because in my entire corpus the maximum sentences that has maximum length is 5, so I have to give exactly that one. And how to find that, we will see that in practical coding. After that I apply truncation will be true, padding will be true, and return transfer will be tf. In return transfer you can pass 2 things: PyTorch and TensorFlow. If you are implementing a large language model in PyTorch, you will have to consider here PT, matlab PyTorch, meaning PyTorch. Okay, but if you are using TensorFlow, then you have to specifically specify TF. Okay, now what are these parameters? So let's do that. First of all, this is the text. this entire text will be converted into integers. Now what are these integers and what are these zeros and what are the CLS and this SEP? Let's see. So first this text will be converted into integer. Add special tokens are coming with BERT models, or you can say large language model, that we are adding before and after the sentences. There are two special tokens, CLS, that is mostly add before the sentence, before each sentence. This is the first sentence, this one. So I just added CLS, and after the sentence I have also added separation, because I am saying to my model that this sentence, if after the sentence you see SEP, it means this sentence will be ended. You have to start. CLS represent sentence start point, and SEP represent each and every sentence separation or ending point. Okay. After that, max length, I am telling to my model that you will have get a lot of sentences, but all my sentences have the maximum length is 5, but in reality it will have 100, 200. We will see that. Okay. I'm sorry. Here I am using reality. Reality means real data. This is just an example. Okay. Now truncation will be true. What does it mean? Truncation and padding are same, but the only difference is we use padding. Now the maximum sentence is this one. So I have give an ID. ID is nothing but the integer value to he, that is 1. He will be known by, model will represent or know he by 1, and nice will by 2, player will be by 3, love will be represented by 4, and intelligent will be by 10. These are integer and it could be considered by model. Okay, we don't need to specifically give it. Now here the maximum length is 5, so it will give 5 integer to the first sentence. Okay, similarly it will give to the second sentence 5 integers, but this sentence has only 3 words, so it will give the first 3 words any IDs. But if you see that there are no further words, it will add 20. Why 2? Because the model says, or the tokenizer says, that I have given a length 5, so I have to make all the sentences equal. Okay, this is known as padding. Okay, that if we have a sentence with 5 length and we have another sentences with 3 length, so we have to add with the second sentences 20 so that it could be equal to the first sentence. Now they have equal length 5 by 5. The same thing goes with the third sentence, and if in your sentence you have only 1 word, so it will give here 1 integer, other 4 will be 0. These zeros are nothing but padding. Why we added? So that we can equal the length of all sentences. Perfect. Now tokenization is similar. Sorry, truncation is similar. Truncation, what to do? Truncation do the opposite. If in your sentence you have 2 words, and in second sentence you have 3 words, and in first sentence you have 5 words, what it will do, it will truncate, it will reduce from first sentences the last 3 words. It will keep only the first 2 words, so that this 2 words, the length of this 2 words equal to the last sentences. Okay, the same thing goes with this. So in padding we add 0 to the smallest sentence, and in truncation we removing or reducing words from the largest sentences. Both do the same thing, equalization, meaning so that it could equal the length of each sentence. I hope you get the idea. Okay, now let's talk about multi-class classification. So normally in NLP project you will get a tabular data. In the first column you will have a text. Okay, a lot of sentences. In the second column it could be any name, but I have given a label. Okay, you will have classes. Now what is the difference between multi-classes and binary classes? In sentiment analysis you have only 2 classes, mostly maybe 3, but mostly 2 classes, positive or negative. So here if the positive class represent all those English sentences or any language sentences that are positive, so here positive is a class that all the text in the entire world that are positive will belong to positive class. Okay, if the class is negative, that all those sentences or words that are spoken by people that are negative will be considered or will be put into negative class. So here positive class put all those sentences into it that are positive, and negative class put all those sentences that are negative into negative class. Okay, so these positive and negative classes are known as binary classes. But what if we have more than two classes? If you have more than two classes, then it is known as multi-class classification. But the main part that we have also discussed what is multi-label, we'll discuss a bit later. But in multi-class you will have more than two classes. So this is a news data set. This news represents tech. All those news in news channels that are talking about technology will be considered in tech class, and all those news from news channel that are talking about entertainment will be put into entertainment class. The same thing goes with politics. Here another sentences will be considered into tech, another entertainment. Right now, how to encode them? So we use tokenizer for this text column, but what we have to do with label? In label we can do two things. Either we have to give explicitly integer value to each class. So wherever you get tech, it will be represented by 0. Here is tech. If the model sees 0, it will be represent tech by 0. If there is another tech, it will be also known by 0. So entertainment will be known by 1, politics will be known by 2, entertainment it must be 1, because there we have give entertainment 1, so there must be 1. So wherever, let's say you have give 0 to tech, so if in your data tech class comes 100 times, so in your encoded level there will be 100 0 before that class, so that each time model know that this 0 represent tech. So this is encoding. But sometimes what we can do normally in large language models, we give list in the sense that we convert these integers to categorical, or you can say one hot encoding. So totally I have 4 classes in my data set. The unique classes are 4: tech 1, entertainment 2, 3 and 4. This is repeated. Actually 1 2 3 we have actually 3, but mistakenly I have added here 4. So let's consider we have 4 classes unique. We have 4 classes. Let's say there we have like another class cartoon type news. Okay, so let's say now if 0 represent tech, I can also encode this 0 or one hot encode, or you can say 2 categorical like this. So I have 4 classes. I can create a list of 4 digits, one with binary values 0 and 1. So here 1 0 0 0. I am telling that wherever you see, I am telling to my model that wherever you see this list 1 0 0 0, this represent this 0, I mean the tech class. But if you see this list, that 0 1 0 0, okay, these are some encoding integers, okay, then it must be 1. 1 is nothing but the entertainment. But if you see something like this, like 0 0 1 0, so actually this entire 2 categorical class represent that we have given a list for each class or each label. Right now let's talk about the same things in another way. Okay, so if I kept all my labels, like I bring a separate column for my tech, for my another entertainment class, for my politics, let's say I have 3 classes, so I can create a separate 3 column. Now in first column in tech, entertainment and politics, I can put 3 values, that if this sentence belongs to tech, then this cell must be on and other 2 cell must be off. Okay, if this sentence belongs to entertainment, then entertainment cell must be on and other 2 cell will be off. And if this sentence belongs to politics, first 2 cells will be off and this cells will be on, because this sentence comes in politics. Okay, so actually the previous part, like this one, is similar to this one. Okay, finally your 2 category encoding will be something like this. So I hope you get the idea. Now let's talk about the most important and most interesting part, multi-level classification. And I hope that you haven't faced such type of problems, because they are quite tricky, and dealing with such type of problem could be very tricky and difficult. Now let's I have another data set with the column text and subject. Forget these 2 columns for now, forget these 2 columns. So in text I have 3 sentences and each sentence represent a subject. I think I have in my deep learning projects playlist, there is a project research paper recommendation system, and subject area prediction. I have solved such type of problem. There in text I have a sentence by the name is CNN is an machine learning algorithm. Now you have to figure out that this sentence belongs to how many subjects. Now here we can't say that we have a class. Actually we have a class subject, but within subject we have a lot of labels. This sentence CNN is nothing but the convolutional neural network that comes from machine learning algorithm. It's belong in computer science. It also belongs to artificial intelligence. It also belongs to machine learning. So the subject could be a class, but within this subject, within this class, we have labels, further labels, 3 labels, right? I have another sentences. Horse can be studied in biology. Now if I figure out the class of this sentence, it could be subject biology, but what if I can further explore its labels? So subject could be biology, but further we can say that its labels are, it could be life, it could be biology. I can also add other, but for now I just added 2. The same thing goes with cosine similarity is used in mathematics. So this cosine similarity comes for calculus, and calculus is nothing but belongs from the subject mathematics, right? So calculus is a label and math is also a label of the subject. Now how to deal with such type of target column, or you can say labels? Here the same process. First of all, you have to figure out all the unique labels. So CS, AI, ML, these are 3, life and biology 5, calculus and math 6. Now it could be possible that there another sentences like logistic regression is a machine learning algorithm, so the label will be similar, so we can't consider that. We'll just consider unique. Okay, so CS, AI, ML, life, biology, calculus, math, we have totally 3, 5, 6, 7. We have 7 currently in this data. We have 7 unique labels for the subject class. Perfect. Now firstly we have to give to each one a unique integer. So CS will be represented by 0, AI will be represented by 2, it could be 1, I just give it 2. ML will be represented by 3, the same goes with 4, 5, 6, 7. Now you have to make it 2 categorical, same like in previous, okay, like this one. Okay, now what you will do for this list, for this entire class, this is entire class, within we have 3 labels. You have to create an entire list. We have this list. Now within this list you will have 6 list. Why? Because we have 6 unique classes. So the first list will be on 1 0 0 0. Okay, second list will be on, and third list will be on. Other 4 list will be off. Why? Because the other 4 lists belong to life, biology, calculus and math. Perfect. In this, the first 3 list will be off because the first 3 list belong to these 3 classes, but the second 2 like 1 2 3 4 and 5 will be on because 4 and 5 represent life and biology, and the last one will be off. Perfect. Now here finally we have calculus and math. So in this entire list, the last 2 inner lists will be on and the other all will be off. So I hope you get the idea. Now why I make these things and why I made this video, because just let me show you, give me a second. This is a playlist large language model in which I have covered in the first video pipeline of transformer. If you have watched this video, you must have familiar that what I'm talking about. Then this was some built-in tools I have used just to show you that you can also use some built-in tools. In the third video I have shown my data. I have fine-tuned a pre-trained BERT model with custom code where I have used all these steps, right? I have used all these steps, tokenizer, this cleaning, and this labels, all these things I have implemented. Now in the next project, that will be a multi-class classification, we are going to implement all these steps. That's why I thought that why I should create a video so that we can make things easy for all the students. So if you have liked this video, then subscribe this channel. And also if you have any questions or any doubt about NLP pipeline and all the steps that I have explained in this video, you can type in the comment section and I'll definitely answer. So thank you so much and see you in the next video.